All right, guys, we're going to do the Unit 8 review. Unit 8 review. Here we go. Determine whether each sequence is arithmetic, geometric, or neither. You remember, we're not doing the geometric stuff, so we're just looking for arithmetic or not, right? So let's change the instructions for one to be arithmetic or not. Okay. So A, let's look at it and say A was 1, 3, 9, and 27. You remember we do the second one minus the first one. 3 minus 1, we get 2. 9 minus 3, we get 6. Automatically, we can stop because those two numbers are not the same. This one is not. B says negative 0.75, negative 0.5, 0.25. So negative 0.5 minus negative 0.75 is 0.25. 0 minus negative 0.5 is going to be 0.5. So automatically, again, this is not arithmetic. And then C says negative 1.37, negative 0.97, negative 0.57, negative 0.17, and 0.23. We look at that and we say, let's see, negative 0.97. I'm going to have to bust out. I think it's negative or positive 0.4. Let me double check my work. Okay, positive 0.4, negative 0.57 minus negative 0.97. You're going to get positive 0.4 again. We got to keep going through all of them, though. Negative 0.17 minus negative 0.57. Get positive 0.4 again. And I think here's where it takes a turn. 0.23 minus negative 0.17. Oh, no, positive 0.4 again. So here we are, is we have 0.4, 0.4, 0.4, 0.4. That must mean it is arithmetic. Okay. All right, on to number 2. Write the formula for the nth term of the sequence. Remember, we only have to do this for arithmetic. So let's see here. 2a says negative 5, negative 3, negative 1, 1, and 3. And recall that our equation is a sub n, that's our nth term equation, is a sub 1 plus n minus 1 times that common difference, right? That common difference. So we're checking to see if it is a common difference first. So negative 3 minus negative 5 gives us positive 2. Negative 1 minus negative 3 gives us positive 2. 1 minus negative 1 gives us positive 2. And 3 minus 1 gives us 2. So our common difference is 2. Our first term is negative 5, so it would be a sub n is equal to negative 5 plus n. You remember, if we have n here, we have n here. N minus 1, and then times 2. That would be our nth term equation. And that's for 2a. 2b, or not to be, that is the question, whether it is noble to live, to die, to sleep no more. All right, while writing down these numbers, you can already kind of understand that this is not arithmetic. It's getting too big, or first of all, it's going negative, positive, negative, positive, negative, right? You can't add or subtract a number and change it from negative to positive over and over again. So I know that that is not arithmetic, so skip. Number 3. Number 3 says, let's see, number 3. It says find a sub 90 for the following. Writing down this sequence 2. Maybe it's arithmetic, maybe it's geometric. Let's do some math first. So we want to know what is a sub 90, right? So we're looking for that first term, and then we're going to add it to 90 minus 1, and then find our common difference in there if it's arithmetic. So let's do that. 13 minus 2 gives us 11. 24 minus 13 gives us 11. 35 minus 24 is 11. And then 46 minus 35 is 11. So it is arithmetic. Our first term is 2. And our common difference is 11. So that would be our 90th term. Plug that into our calculator. 2 plus 90 minus 1 times 2. Oops, hit tangent. Times 2. And we get 180. So a sub 90 is equal to 180. All right. Number 4. Here's a pattern made of toothpicks. Write the formula for the nth term of the pattern. How many would be needed for the 25th figure? Okay. So number 4 has the toothpick pattern. It's a pretty popular question. Maybe a different shape of toothpicks, but the toothpick pattern. So 1, 2, 3, 4, 5, and 6 in the first term. So the first term is 6. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for the second one. Notice that there's not, this one counts for both of those, but there's 11. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 for that third term. We need to find our common difference. 11 minus 6 is going to give me 5. 16 minus 11 will give me 5. So we know it's arithmetic. Write the formula for the nth term. So a sub n is equal to the first term, 6 plus n minus 1 times our common difference, 5. Now it wants to know what is the 25th figure. How many toothpicks will we need for the 25th figure? A sub 25 is equal to 6 plus 25 minus 1 times 5, and we will get 6 plus 25 minus 1 times 5, and we'll get 126. So we will need 126 toothpicks for a sub 25. All right, number 5. Number 5 says the table shows the canceled check fee for a bank from 2000 to 2020. Find the equation for the line of best fit that models the data, and X represents the number of years. Okay, so we're just plugging this in. We know it is what kind? It is doubling each time, right? So it is linear. It says it's linear. All the answer choices are linear, right? If we're on number 5 here, look at our answer choices. None of them have x squared, and none of them are to the power of x. Remember, x squared is quadratic, and to the power of x is going to be exponential. All of these are just x to the power of 1, so they're all linear. So let's plug this in for a linear regression. Instead of 2000, we're going to put in 0. And then instead of 2005, we're going to put in 5. 2010 will be 10. And 2020 will be 20. Okay, the fee is 5, 10, 20, and 40. Stat over to linear regression. And there it is. So number 5, it is going to be y equals 1.8x plus 3. That is C. All right, number 6. Number 6, make a scatter plot relating time spent studying which of the following can be concluded for the graph. Okay, so we're supposed to graph, and it gives us a graph. Let's see here. By the way, this little lightning bolt just means skip from 0 to, I think the first line above that is what, 50, no, 40, yeah, 50, 60, 70, 80, 90, 100. And then we get 10, 20, 30, 40, 50. It just assumes none of you are going to score less than a 50, right? First one, 10 minutes studying. This is minutes. This is grade. This is grade. This is minutes. Minutes. And this is grade. So 10 minutes studying, you got a 53. Congratulations. Woo. 20 minutes studying, you got a 67. 30 minutes studying, you got a 78. Very close to 80. 40 minutes studying, you got an 87. So close to 90. And 50 minutes studying, you got a 95. Way to go, you. All right. Now we look at our answers. We have A, B, C, and D. A says a decrease in time spent studying causes an increase in score. Is that true? As we decrease, do we increase? No, or else it would be facing this direction, right? This is as X increases, Y increases. This would be as X increases, Y decreases. So A is out of the question. B, an increase in time spent studying causes an increase in score. That is true. C, an increased score causes a decrease in studying. No, because X is the independent variable, Y is the dependent variable. So time is independent. Your score doesn't cause a decrease in studying time. So C is out of the question. D, no conclusion can be reached from the graph of data points. Of course it can. We have a nice positive correlation right here. So that's going to be B. Number 7. What is the 8th term of a sequence with that stuff? Number 7, we're going to skip because we see multiplication 2 times f of n negative 1, right? So this right here, we're going to skip that one. Number 8 says, what is the 30th term? We're going to do this one. We need a sub 30. We know that it's a sub 1, which T1 is 10, plus n is going to be this number right here. So 30 minus 1. And then it says minus 2 on the back of the equation. So that is our common difference here. So we're going to plug that into our calculator. 10 plus 30 minus 1 times negative 2. We get negative 48. So a sub 30 is going to give us negative 48. All right. 9 and 10, use the data in the table showing the number of congressional seats appointed to California each decade. Yay. Find the equation for the linear line of best fit around the nearest thousandth. Which of the following represents the correlation coefficient? So remember, you need to make sure that your correlation coefficient is on, and then we will use a stat. I don't think this is correlated. I think it's this calculator. So stat, calc, this one has the, remember, this is going to be our linear correlation coefficient. So let's edit this data. 40s is going to be your 0. Your 0 is 40. 1950s would be 10. 1970s would be 30. 1990s would be, 50? And then 2000s would be 60. Because we started in 1940. 23, 30, 43, 52, and 53. All right, so it said it is linear. And the equation, find the equation, and it wants to know the correlation coefficient. So the correlation coefficient is 0.985, which is 0.99, and that is a positive, right? So it is B. Number 9 is B. It is a 0.99 strong positive correlation. Number 10. See if I can get number 10 done in less than a minute. Use the regression equation to predict the number of seats appointed in California in 1930s. So we're going to pop this equation in for 1930s. That's negative 10 years. All right, I'm going to hit pause so I can type it in my calculator and not lose time. All right, so this is the equation that I typed in my calculator. It's a little bit jumbled, but all I did was plug in the A for M and the B is for B. There it is right there. Hit table. Go to negative 10. And we see, because you remember 0 is 1940, so negative 10 would be 19.585, which would be 20. So D, 410. All right, next video coming right up.